So in this video, we're going to look at the concept of periodicity and trig functions. And so the concept of periodicity helps us evaluate trig functions and understand how do we analyze trig functions at really high angle values. And of course, this concept of periodicity is, what makes the trig functions powerful and why we use it in practical implications. But let's go ahead and look at this. Let's say we have 45 degrees and I were to add 360 degrees. And so that is 405 degrees. Now remember, these are coterminal angles. And so if you remember, the values at 45 degrees and the values at 405 degrees are the same. Now if we were to look at 45 degrees as pi over 4 and add 2 pi to that, what is that? Pi over 4 plus 8 pi over 4, which is 9 pi over 4. So these are coterminal angles. And so if we were to look at our unit circle right here, so here's pi over 4. 45 degrees, pi over 4. If I were to go all the way around and have, 405 and 9 pi over 4, we end up at this exact same spot. And what happens is the x and the y values are still the same. And so that's kind of the concept of a periodic function. That I start here, I go all the way around, and I'm back at the same thing. And I go all the way around, and I'm back at the same thing. And so that so in this case, every 2 pi radians, we just keep on repeating over and over and over again. Right? So let's go ahead and write out the definition of a periodic function. But the concept is that you just keep on repeating. Alrighty. So a function f is periodic if there exists a position, no, not a position, whoops, positive, I misread that, positive real number C such that f of t plus c equals f of t. Okay. The smallest number c for which this holds true is the period of f. Okay, so let's go ahead and take a look at how this works. So we already started with the idea of pi over 4, and so we're going to continue with pi over 4. Now we know the sign of pi over 4 equals the square root of 2 over 2. Now we took pi over 4 and then we added 2 pi to it and we got to the same position. So one full revolution of the circle is 2 pi. Revolution of circle is 2 pi radians. So if I were to take, for example, the pi over 4 and add 2 pi, which we already did, that was 9 pi over 4, then we can say that the sine of 9 pi over 4 equals the square root of 2 over 2. Now we could do another revolution. We could say pi over 4 plus 4 pi. So that's going to be pi over 4 plus 16 pi over 4, which is 17 pi over 4. So that means the sine of 17 pi over 4 is also the square root of 2 over 2. And we can keep on doing this and doing this and doing this. We keep on going around and around and around the circle. And we would always get a sine of the square root of 2 over 2. Now, because we can keep on adding 2 pi to it, that means the period of sine is 2 pi. Now, of course, this is the way it works when it goes to cosine. I mean, the period of cosine is also 2 pi. Okay, so let's see how we can use this concept of the period to help us evaluate trig functions. Let's do a couple of examples. We're going to evaluate the cosine of 8 pi over 3. Now when we go to our unit circle and we look and we're like, well, 8 pi over 3 isn't on our unit circle. And that would make sense because 8 pi over 3 is bigger than 2 pi. You know, so if you had pi over 3, 2 pi would be like 6 pi over 3. So what we're going to do is we're going to take 8 pi over 3 and we're going to subtract 2 pi. So that's 8 pi over 3 minus 6 pi over 3, which is 2 pi over 3. And we look at our unit circle, and 2 pi over 3 is on our unit circle. So this means the cosine of 8 pi over 3 equals the cosine of 2 pi over 3. And the cosine of 2 pi over 3 is negative 1/2. So that means the cosine of 8 pi over 3 equals a negative 1/2. And so what we do is we use the idea that cosine is a periodic function to evaluate a cosine angle, the cosine of an angle, using our unit circle and the fact that it is periodic. Here, let's try another one. Let's say we want to find the secant of a negative 2 pi over 3. So of course the secant, we're going to have to figure out what that is. What is secant? That's 1 over cosine. But it doesn't matter. Negative 2 pi over 3 is not on our unit circle. There are no negative angles on here. So because we're negative, you notice up here we started off with a positive angle and we subtracted 2 pi to get back to the unit circle. When you have a negative angle, we have to add 2 pi. So a negative 2 pi over 3 plus 2 pi is a negative 2 pi over 3 plus 6 pi over 3, which is 4 pi over 3. And 4 pi over 3 is on the unit circle. So that means the secant of a negative 2 pi over 3 equals the secant of 4 pi over 3. Those are the same. One thing I do want to clarify is these are not the same angles per se. I mean, they are at different, rotations, how we got there. It's just that the trig functions evaluated at those angles end up being the same answer. Okay, now secant's 1 over cosine, so now we have to find 1 over the cosine of 4 pi over 3. And we go to our handy-dandy unit circle, and here's 4 pi over 3. The cosine is a negative 1/2, so it's going to be 1 over a negative 1/2, which is a negative 2. So that means the secant of a negative 2 pi over 3 equals a negative 2. And there you go. All right, so it does take time. I mean, you kind of have to figure out where you are. You have to determine, well, I'm not on the unit circle. How do I get to the unit circle? But the basic concept of the periodicity of the trig function, specifically sine and cosine, is that if we keep on adding or subtracting 2 pi, and at some point we get back on the unit circle, then we should be able to evaluate that trig function based on the unit circle.